All right, welcome everybody. This is Mr. Spinks. We're in section 3.2, first video of 3.2. Now today is where it really steps up because we're going to be able to put together truth tables based upon the logic we learned last section. That's the plan, okay? Now, talk about what a truth table is to start because you're probably thinking truth table, what the heck are you talking about, Spinks? So here's the idea. A truth table is a table, well, that's a duh part, but the purpose of it, it's used to determine whether compound statements are true or false. Kind of the idea. And it looks like this. Now, we developed this. We kind of put it together, okay? There's a little trick for putting it together, so make sure you're paying attention. First thing I do, I always write in on the side where I'm basically basing it off of true and false, okay? So P has choice of either true or it could possibly be false. And we go to the other side. Well, if P is true, the negation of P is the reverse of it. So if P is true, negation of P is false. And if P is false, the negation of P is true. Seems simple, right? Well, let's keep going and make sure we understand this, okay? Now, this has two variables. So every time you have two variables, and there's no decisions being made here, you're just learning how to load a truth table. What you do, you start always by making the first two true. And you're listing out all the possibilities can occur. If I've got two variables, they can both be true. Or maybe the first one's true and the second one's false. Or maybe the first one was false and the second one's true. And the last possibility is that both of these entries could be false. All I'm showing you now, though, is how to load a truth table. That's all that is. There's no decision-making process there. That's just automatic right there. All right, now here's some decision-making process. This is the decision part going on right here, okay? It starts, okay, well, we load the variables. We have two variables, P and Q. What are the choices? They can both be true. First one could be true. Second one could be false. First one could have been false. Second one could have been true. And on the last one, they could both be false. And you got to know what your operating symbol is over here. Over here, that's an and. The little tent is an and. Now, for and to happen, both have to be true. It has to be true and true. So here at this top level, P is true and Q is true. So both are true. That's an and. However, on the next one, P is true and Q is false. Well, this doesn't work with and. With and, they both have to be true. So if they're both not true, this must be false. Same occurs at the lower level here. Just because Q is false, or Q is true, P is false. Once again, for an and symbol to work, both sides have to be true. Both sides are not true, so this is also false. And on the last one, they're both false. Well, they're certainly not both true. And that's how and works. For and to work, both sides of it have to be true. True and true is the way it works. So we've got and right there. I also need to show you or. Now please understand, we're just showing you how to set up truth tables right now. That's all I'm doing, okay? On the next one, we're going to do the same thing. We're going to do or at this point in time, but we're going to load the truth tables the same way. Both variables could be true. Maybe the first one's true and the second one's false. Maybe the second one's false and the first one's true. Or maybe they were both false. Now, unlike and, with or, if either one of them is true, it's a true statement. Because it's or, either or. If either or is true, it's true. Well, look at the first one. They're both true. So, well, either or is definitely true if they're both true. On the second one, there's one true, one's false. Either or is true. One of them is true. This is true. That's the difference between and or. For and, they both have to be true. For or, if either one of them is true, it's true. The only time you're going to see or being false is if they're both false, like there is at the lower level. Okay, so that's just us setting up some basic truth tables, trying to help you understand what's happening with truth tables. So that's how it works with two variables. Last one we're going to do is with 3 variables, okay? And with 3 variables, there's a particular way that makes it very, very easy to load the table. You start, this is just loading it. I'm showing you how to load a table with 3 variables. You start with all 3 being, or you start with 4 trues in a row of the P. And then you go 4 falses. This is just how to load the table, how to set it up whenever you've got 3 variables being involved with it. For the second one, you're going to go 2 trues, then 2 false, and repeat the pattern. True, true, false, false, true, whoop, true, false, false. Again, 2 trues, 2 falses, just repeat the pattern. And on the last one, you go true, false, true, false, true, false the whole way through. True, false, true, false, true, false, and finally true, false. And I'll zoom out and let you see the whole table in a second. It's a good, easy way to always load a 3 different variable table. Notice there are 3 different variables, P, Q, and R. Start with the P's, go 4 true, 4 falses, then do 2 trues, 2 falses, 2 trues, 2 falses, and then just go true, false with the other side. Easy way to do it, just the easiest way that I've ever seen, guys. Just try to make your lives easier. All right, so here's how we go do the whole bit to construct a truth table. We start by determining if the overall statement is a negation, conjunction, or disjunction. We then complete the columns under the statements P, Q, and R, and their negations if it's necessary. We then do the connectives, the parts in the parentheses. Once everything else is completed, we will take care of the operating symbol outside of the parentheses, and that is the actual answer. And we always circle this column to make sure that we know what we're talking about. Well, I have to show you an example of this for this to make sense. So I'm going to show you a very basic example, okay? Talking about 2 variables, P and Q. And with 2 variables, they can both be true. That is possible. You can have, let's get that one true, the other one false. It's possible for the first one to be false, second one to be true, or for both to be false. Well, what we're going to do this for P, and the negation of Q. And what I always do is I draw different columns underneath them. I'm going to separate these guys because I'm going to evaluate them individually. Now understand, this column right here will be the answer column. Because as I told you before, we always load the columns around it, the variable columns, then the answer column is the one in between them. So how do I load P? Well, I just look at the P column and load them as they go. The first one was true. Second one was true. Third one was false. Fourth one was false. How do I load negation of Q column? Well, look at the Q column and do the reverse of it, because that's what negation is. So the reverse of true is false. The reverse of false is true. The reverse of true is false. And the reverse of false is true. And the answer column is what comes in the middle, and I will use red for that. To do the answer column, you're just looking at this point in time. That's the only thing we're focusing in on is this. Everything else was used to set this up. All right, this is and. For and to be true, they both have to be true. Well, here one's true and one's false, so they are both not true, so that one's false. Here on the next one, they are both true, therefore that one's true. On the next one, they're both not true, so it's false. Remember, with the and symbol, they both have to be true, and here they're both not true, therefore it's false. This is the answer column right here in the middle, and we always circle the answer column to make our teacher's life easier. That's a truth table.